Descriptors are so powerful, I can use them to control you, and yet they're so simple, I'm going to explain how they work in the next 40 minutes. So thank you for the introduction. My name is Rodrigo, and I wanted to make sure that everyone here knows a little bit of Python at least, by show of hands. Now, please keep them for a second, and take a look around to see how many hands are up. Okay, excellent. Now, how many people have used descriptors before? Now take a look around. There's fewer hands up, right? Just bear that in mind. Now let's do some live coding. Is this readable from the back? Can everyone read this? Okay.
Is a so and so in the back?
There's a what?
A so and so in the back, so very slightly bigger. Okay.
Yeah, can we dim the lights, please? Is it possible to dim the lights? Okay, so while we check for that, let's see if we can zoom in a bit. It's not the same thing, but it might help a bit. Okay. So the thing is, I want to explain how the descriptors work. And to do that, I'll start by defining a class person. And I'll define an init method that has nothing to do with descriptors. And I'm going to say that the person is going to be initialized with its first name and its last name. Yeah? Feel free to, if something doesn't make sense, feel free to interrupt me. It's a small enough room that we can interact a bit. And so what I'll do here is I'll save my first name for later. I'll save my last name for later. And I'll also, perfect, it's better. Excellent. And now I'll also save my full name, which is going to be my first and my last. Is everyone okay with this piece of code? It shouldn't surprise anyone. Now what I'll do is I'll run this piece of code. And now what I have here is a class person. Yeah? And I'll create a John Smith. Just a random dude. I've got John there. Now what's the name of John? If I press enter, what do I get? Okay, excellent. Now, let's say that John Smith is no longer Smith, but rather Serrão, which is my last name. If I type john.name, what do I get? Okay, which is wrong. This is a problem. And typically the way we solve this in Python is by using a property. It's the property decorator. The issue here is name, the attribute name, has dependencies on two other attributes, and yet we only compute it once. And so when the first and last attributes change, name becomes outdated. And the way we typically do this in Python is, or the way we fix this is by creating a name method. Thank you. The applause is for me, I'm sure. We create a name method, and instead of assigning something, we return the value we care about. Now in here I need to access my attributes. And this is currently a method, so what we do is we add the property built-in that turns the method into an attribute, right? So let's run this again. I've got my person, I have a John Smith, and if I do john.name, I get John Smith. And if I change the last name of John to Serrão, and if I do john.name, what do I get now? John's, yeah, so it's not, yeah, exactly. So the pronunciation is difficult, but we all agree that it's not John Smith. Right. No, but good. It's not a, yeah, okay. We can talk later if you want to get my name right. So what the key thing here, the thing that I think you pretty much already understand, is that this looks like an attribute from the point of view of the user, but it's actually defined as a method. So property turns methods into attributes. Okay? And if you're comfortable with this, there's no way you won't be comfortable with what I'm about to show. It's no way. So let me put this on the right. Let's create a new file. Let's call it, naming is hard. Let's call it desks2. Sure. And now let's put this on the right. split right. And now what I want to do is write a descriptor on the left that does the same thing as what's on the right, because we will see that they're actually similar. And so this side by side will help us understand how things work. Is this still readable? I just decreased the font size. Okay, brilliant. So what's a descriptor? Well, a descriptor is an object. Thank you. I'm glad you're paying attention. Exactly. So a descriptor is an object, but that's not saying much because everything in Python is an object. So what's special about descriptors that makes them descriptors? If you were here before, Adrian said that there's a specific method that we want to define. So a descriptor is going to be a class that I'm going to define on the left that is going to have a very specifically named method that is going to mimic this behavior of the property on the right. So let's call this the name descriptor so that we all agree that it is a descriptor, even though I haven't done anything yet. So the implementation is yet to be seen, and the way it's used, the way descriptors are used is as class attributes. So in my class person, if I want name to make use, if I want the attribute name to make use of a descriptor, I need to define it at the class level, and I say name equals, and then I make use of the descriptor by creating it, by instantiating it. And now the question really is, what do I need to replace the ellipses with so that the code on the left behaves in the same way? So this is the question. And the answer turns out to be, if I define this get method with the double underscores on the left and on the right, then I will have a descriptor. And what does this weirdly named method does? This method is responsible for getting the value of an attribute. And so the descriptor will also turn methods into attributes. Or if you look at it the other way, you can use something as an attribute and it will run a method for you. So you have more power to do things that you need, because if you're running a method, you can run whatever code you like. So it allows you to do dynamic things when accessing an attribute. And so what does this method receive? It's a regular method, so self goes first, then, and this is where the fun begins, then we do object. And this object is going to be a person. So this is the thing that has a name. John Smith has a name, and so when I call the name of John Smith will end up here in the object parameter. And then there's a third one, which is the object type. And we will see why this matters later. But for now, it doesn't matter. And so now what do we do if object is a person, and maybe I should actually call it person. So if object is the person that I care about, how do I build the name? Well, I just access first and last and put them together as before. So I can even copy this. Because this is what, I don't know about you, I'm a great programmer because I'm great at copying and pasting. It's what I do best. And that's it. I'm returning. Is anyone surprised by the f string? Okay, excellent. So then, this code implements a descriptor. It's not a very interesting one, and please, I'm not saying that the descriptor on the left is better than the property on the right. I'm not saying that. I'm just making the comparison so that we understand how descriptors work, because this is preferred, the right one. But the left one does the same thing, and I'll prove it to you by running the code. So let's get out of here. Let's do this. Let's run desks2, because that's where the descriptor is. By the way, the -i lets you run a script, and by the end of it, you get an interpreter session with everything that was defined, in case you didn't know, so quite useful. So you can see the name descriptor, for example, is in here. It's defined. And let's create a John Smith. Copy-pasting, scrolling up the history, more or less the same thing, right? And so John.name, what do I get if I press enter? I get John Smith, and this is where the fun stuff happens, because this looks like an attribute from the user point of view, but what's going to happen actually is, I'm going to go access this. There's nothing specifically defined in this instance, so we're going to look for name in the class, and the class person has a name. Oh, it's that name descriptor object. Oh, but wait, this name descriptor object has the method get. And so Python will call method get for us. It will put this John here inside the person, and then I get John Smith. Is everyone comfortable with this? Okay, then it should come as no surprise that if I update the last name to be Serrão again, Serrão, exactly, that was good. Then, if I check the name, what do I get? I get John Serrão, which is an odd name, but at least it's correct. It agrees, it matches with the self.last. Is everyone comfortable with this? Excellent. Yes?
Thank you. Sorry for the English. I don't understand how the how the attributes from person is passed to named descriptor.
Okay, excellent question. So how do I get access to these first and last thingies, right? Excellent. So if I go ahead and if I print, say, I'm inside get. I don't know if you do advanced. I do print debugging most of the time. I only know how to copy and paste. I don't know how to use a proper debugger. And now what I'll do here is I'll print person, and I'll also print. I'll just print person. That's going to be enough. So if I print these two things, I'm going to go ahead and I'm going to exit the file, run it again. I'll create my John Smith. Notice how nothing was printed because I didn't access my descriptor. And now if I do, just posing for the picture, sorry. And now if I do John.name, again, this is where the fun stuff happens. This looks like an attribute, but how does this actually work? Notice how this is, sorry. This is a dictionary. Do you see the dictionary? Do you see a name in here? Excellent. So the John object, the thing, John, doesn't have a .name. So when I do .name, Python looks for the name in here, it doesn't find it. And so it goes up a level. This was the instance. Now it's going to look in the class. John is a person, and the class has a name. I'm just pointing for people that were watching the stream, I'm sorry. So the name is inside the person. So when I do John.name, I'm going to fetch that name, the name descriptor. The name descriptor is an object. And Python will check behind the scenes. We don't see it, but behind the scenes, Python will see if the name descriptor has a very specific method. A method called __get__. And because it does, Python will call that method over there at the top. And Python will take this John and put it inside person. Python does it for us. And so when I do this, I get the prints. I get I'm inside get, it's over here. And then when I print the person, I see the print here. And take a look at the ID, it ends with 1465D0, and if I do John, it's the same person, 1465D0, so it's the same object. Excellent. Is it clear for everyone? Brilliant, so let's keep going. So this is a part of a descriptor, but actually descriptors have more things to it than just this. There's more things that can make a descriptor, and so we will take a look at them. And again, we will start by drawing a parallelism, drawing an analogy with the property decorator. Because if I do this, I should really rename this file. This is going to cause so much confusion. Not for you, for me. So this is the properties file, and the other is the descriptors file. This looks like a more reasonable. I'm almost eating my microphone. So this looks more reasonable. So if I run the properties, I have a John again. And if I do John name equals, I don't know, let's change the name to John Serrão. What will happen if I press enter? I get an error. Some people say no. I don't know if they don't know or if they just say, yeah, Rodrigo, that's not going to work. It doesn't work. My attributes, and notice how they talk about properties. My attribute doesn't know how to set things. So it's a one-way street for now. I can get things, I can't set things. But property lets you set things as well. So what I'll do is I'll create another method. And so this isn't the usual convention, but just for the sake of clarity, I'll say, let's call this the name setter. And so this is a method that I want to run to update the name, which really means just updating the first and the last. And so if I want to be able to set the name, I need to accept a name. And then let's just say, for the sake of simplicity, that the name will always have a first and a last, so I can just split. And now I set them. Is everyone comfortable with this? Okay. Who said no?
No, I said cool.
I misheard. I have the hearing of a, yeah, I have terrible hearing. So we do this. And the method works, but what we want is we want to make it look like I can set the attribute, because there's an attribute that we can fetch. And we do this by using the setter attribute of the property. So name is a property, we put the setter there. Is everyone comfortable with this dot setter? Brilliant. So then, if I run this, I run it, I create a John Smith, and then if I do john.name equals John Serrão, what happens if I run it? Nothing visible happens. Whoops. What did I? Sorry? No, it's the correct file. I did something stupid. Def name setter. Let's see. It doesn't make sense that this is the. Sorry? It should be exactly name. Okay, so maybe it should. And I'm just doing weird stuff. Okay, great. Okay, so then apparently the name must really match, otherwise the property decorator won't understand that that's supposed to be a setter. But the code, I didn't change the code, I changed the name. And now property is happy about it. So nothing visible happens, but hopefully, now I'm nervous, hopefully the last name changed. Okay, good. Yeah. I was honestly a bit nervous there, but yeah. So what's interesting here? The interesting thing here is, again, I'm going to keep saying the same things over and over again. John.name looks like an attribute. This looks like a regular attribute assignment. And yet, when I do this, notice that this is actually being, there's a dot there, and the dot does something in Python. So I'm looking up the name. Again, same story. John itself doesn't have a dot name. It's the class that has it. And so when I do John.name and I go into the class, exactly. And when I go into the class to check for a name, I will find that method over there, this here, that is tagged with a dot setter. And so Python will know that it has to run it. It has to run that method with this string as the name argument to do the assignment. And so then we just do the assignments in there. And so we can do this, we can do the same thing with a descriptor. Again, I'm not saying it's going to be better, I'm just saying that there's an analogy there. So let's do it. Let's split this to the right, and now let's see if I can change the correct file. Brilliant, so descriptors. Now, who wants to guess, if you already know, please don't reply. Who wants to guess what's the name of the method that I need in the descriptor? So the get gets things, so if I want to set something, what's the name going to be called? The underset, brilliant, exactly. So a descriptor can have a method called underscore underscore set underscore underscore. And again, this is a regular method, so self goes first. And then what do I need? I need the person that I care about, and I need the new name. And then the code is going to be exactly the same. This thing here, the split and the assignments, they're the same. So I can just copy this, and I can just fix this, because it's no longer in self. Again, inside the underset, self is the descriptor. I want to change things in the person, so this is person. At a first glance, is everyone comfortable with the code? You better be, because I just copied things around. So it's the same code. It's the same code. Now let's do this, and let's run it, and see if I broke something or not. Now let's run the correct file. Let's see. I'll create a John Smith, and I will assign the name to John Smith. It's a good sign, at least I didn't get an exception. And now let's see, moment of truth. So I did update the last name. Can everyone, let me delete this. Let me close this. Can everyone kind of see what's going on? You're just liars. There's nothing to be seen. There's nothing to be seen there. So I'll just add a couple of prints to make absolutely sure that everyone sees what's happening. So this is, I didn't mean to offend you, but I just don't like when people say, yeah, everything is fine, and then no, okay. So this is set. By the way, personal tip: when you're exploring Dunder methods, does everyone know the term Dunder methods? You can ask me later if you don't. So when you're exploring these things, adding prints all over really is helpful because it helps you understand when things are being called, because there's just too much stuff happening. And now I'm going to run exactly the same code, so I'm going to create a John, and I'm going to assign a name, and when I press enter, you will see that those prints, the prints inside on lines 8 and 9, those will be triggered. So on the count of 3, 1, 2, 3, there's the prints. Yeah, and this Girão Serrão here comes from it's person colon common name. So there's the person and then the name. And now if I check, it's obviously still the same, as in still correct. Questions so far? No questions? Excellent. So now let's do an exercise. So I'll create a new file. Let me call it, I don't know, colors. And what I want to do is I want to create a class. And I want to say that my RGB color is going to accept a hexadecimal code. Is everyone comfortable with hexadecimal codes for colors? It's just a representation, right? So for example, let's see, F8, F8, F2, this is a kind of, it's a shade of white. This is a color. And it's hexadecimal because it's digits from 0 to F. So I want to do this. And now what I actually want is to save, obviously, the hexadecimal representation. But I want to be able to say something like, so let's create my red color. And red in hexadecimal is something like RGB, so that's going to be this. This is a very bright shade of red. And I want to be able to do something like print red.r. So I want to be able to get the R component. I want to be able to get the green component. And I want to be able to get the blue component. I want this code to run, I just need to fill in the gaps. And the issue here is the same as the issue with the person, because I have different attributes that depend on each other. And so I need to be careful because I want updates on one of those attributes to reflect on the others. So there's this dependency, and that's why I need dynamic behavior. That's why property is relevant, and that's why the descriptors also work here, because they let you do dynamic attribute retrieval and dynamic attribute assignments. So how do we fix this? With a property, I would need to write 3 properties, one for R, one for G, one for B. With descriptors, I can write a single descriptor. And so when I first understood descriptors, the way I thought about them were kind of like property factories. So instead of writing 3 different properties, I'm going to write 1 descriptor to replace them all. So there's, one descriptor to rule them all, right? So that's the original quote. So I'll do my RGB component descriptor. And again, the name ends with descriptor, just so we're clear that that's supposed to be a descriptor. And now, this is where stuff gets fun. If you weren't having fun yet, this is where it should get fun. I want to use 1 descriptor, so 1 class in line 1, to implement 3 different attributes, R, G, and B. So there obviously must be something that lets you distinguish between the descriptor for R, the descriptor for B, and the descriptor for G. Because they're supposed to give different results. But I want to encapsulate all of that behavior inside the descriptor. But surprise, big news, I'll break it to you. That's a regular class. Python code works because this is Python, right? So if this is a regular class, it can have an init method. And if I can have an init method, I can say, for example, I can specify the positions of the hexadecimal code where I can find the appropriate component. So let's just say that I'll accept a position and I'll save it. And then, in my dunderget, which is the method that will run when I access the attributes, I'll be able to do something with this position. So what are the arguments that go in? What are the parameters? Do you still remember? Yeah, so this is going to be a color, whoops, a color, and then something. We don't talk about that, at least for now. Now, how do I get the appropriate component inside my descriptor? Well, I need to make use of the position. And so I'll do return color.hex, and let's slice it. So that's going to be, I can't type a lot here because otherwise it's going to go off the screen. So let's do the following. Let's do self.pos. And so this should be p+1, p+3. And now let's turn this into an integer, because why not? 16. Everyone comfortable with this piece of code? One thing that bothers me is that Black doesn't agree with what I wrote, and so Black reformatted it, but then Flake doesn't agree with the spaces here, so I don't know, they just like to fight. And if I run this, will this work? If I run the code, will I get the R, the G, and the B? I won't. Excellent. Why not? Because I haven't used the descriptor yet. Guys, please pay attention. So I still need to use the descriptor. How are descriptors used? You set them as class attributes in the appropriate class. Now, will this work? Okay, the red underlines gave it away. What am I missing? The position. So this is going to be, how did I define this? Yeah, I'm glad you're paying attention. Yeah, it is. So this is actually kind of stupid. But sure, it's going to run, so it's fine, I think. Now, what do we expect as outputs here? So what's supposed to be the output of red.r? Nope, because I'm converting the integer, just for extra confusion. And then these are going to be 0. So if everything goes well, we get that. Okay, we got it. So take a look. Let's, sorry, so the output is there. And I reckon the descriptor is more interesting than this. But this is not going to work, right? Of course not. So what I'll do is, I'll put this here. And actually, I won't do anything because I can't. I wanted to show you the code. Everyone comfortable with this? All right, so what have we seen? We've seen that I can use a descriptor for multiple attributes. We've seen that dunder get runs dynamically when we try to access attributes, and dunder set runs dynamically when we try to assign to attributes. Now let's do one thing that's even more general. Which one do I want to do? All right, let's do, yeah, I was thinking and I've decided. Let's do a descriptor.
Short question about the approach. I want to write a question. Maybe we should design the classes with method instead of attributes and property, solve a lot of issue and cost of extra parentheses. But perhaps it's a matter of the approach that we're following.
I didn't understand the question at all. Can I read it, please?
Yes,
Sorry.
it's anonymous, but if someone wants to work.
I'm going to read it aloud. So maybe we should design the classes with methods instead of attributes properties. Solves a lot of issues at the cost of extra parentheses. Okay, so I would rather we don't go into philosophy because I'm not in a position to discuss it. So assuming as an hypothesis that the Python standard way of doing things is fine, this is how we do it. The discussion of whether we should have getters and setters or not is a whole new discussion. So let's just focus on, let's assume that properties make sense, and thus descriptors make sense. Other questions? I mean, you can ask philosophical questions, but I'll just decline to answer.
Is property implemented using descriptors?
Let's get to there later.
Okay.
That's a good question.
Thank you.
Thank you for your question. So if you didn't hear the question, that's fine, because they're spoiling my talk. So, alrighty, everyone fine with this? Brilliant. So let's do one final thing. In Python, there's another convention. There's this one person, I mean, there's plenty of people I like, but there's one Python educator that says that Python is a language for consenting adults. You can't really prevent anything from happening, but there's certain standards and conventions that we all agree to uphold. So for example, if I were to redefine my class person, but if I were to say something like, Do you ever do this? I always do this. I do the two leading, but then I forget the two trailing. And then my code doesn't work, and I wonder why. So let's do the same thing, but now I'll write self._first equals first, self._last equals last. Has anyone ever seen this convention of the leading underscore? Right. It's the convention to say this is private, please don't touch these attributes. However, we don't do protected here. That's Java land. So sorry if you have to write Java code. So let's just run this. Let's run the private. It's not even private, because what I can do is I can create a poor John Smith, and I can do John first equals Rodrigo. I'm very self-centered if you haven't realized yet. I can do this, and it works. There's no exception here saying name was protected or private. There's no such thing. So now let's write a descriptor that enforces this, so that it hides this behind a wall. Or rather, let's mimic this behavior. If I do, again, using property, I could do something like def first. And if I do return self.first, what am I actually doing? I'm creating the getter without creating the setter. And therefore, if I try to set, so John.first works. Nope, it doesn't. Yeah, thank you very much. You were paying attention, that's good. You're passing all of the tests. So if I do John Smith, John.first, this works fine. And if I do John.first equals Rodrigo, it doesn't matter the spelling because it doesn't work. So there's an attribute error there. Yeah? Why? Because we didn't define the setter. So let's mimic this behavior with descriptors. And now what I want to do, and that's why I went through all of this trouble, is I want to write one descriptor, so one class, that I can use for all of the attributes in all of the classes that I want to make read-only. So in here, for first, I needed one getter. If I wanted to do it for last, I would need another getter. If I wanted to do it for other classes and other attributes, I would need to define one getter per each. I'm tired just from saying it. Imagine if I had to write it. So what I want to do is one descriptor to rule them all. That's how it goes. One descriptor to rule them all. So we'll do the read-only descriptor. Again, it's not the name that makes it a descriptor, right? We already know that. Now, we need a getter here. And this is where things really get interesting. So I no longer receive a person or a caller, I just receive a random object. And in here I'll receive let's keep avoiding this subject. I receive something else. And now, what do I do there? What do I type there that's going to solve all of my issues? Because if you think about it, it's going to look silly. It's going to look very silly if the way I do this is by saying first equals, if I manage to type it. I don't want to do this. I don't want to have to pass the name of the attribute into the descriptor, because that's just asking for trouble. I will eventually, I'm not saying I might, I'm telling you I will change the name of the attribute and forget to change the call to the descriptor. I'm going to forget that. So I wish Python was smart enough to provide me a way for this to work. So let's just, if we wish really, really hard, then maybe, just maybe, there will be a way to do this. Thank you. And so what we will do now is actually realize that there is a way for this to work, and it's brilliant. There is one extra special method called setName. setName. This is __setName__. Now, it has nothing to do with descriptors, so the presence or the absence of this method does not influence whether a class is a descriptor or not. But it's very useful here, because what setName will do is, or rather, what Python will do with setName is, when a class is defined, when this happens, Python will instantiate read-only, it will assign it, and because this thing here has a setName method, it will call it, and it will say, hey, by the way, this specific class received these specific attributes. And so I get notified, as a descriptor, I can get notified of the class that I was assigned to and the name that I was given. And this is just brilliant, because now what I can do is, I can obviously save my own name. It would be ridiculous if people went around and said, what's your name? And I don't know. So we save it for later. And now when we try to access the attribute, what do? We do some dynamic lookups. We will return the get attribute of what? Well, the attribute lives inside object. What's the name of the attribute? Well, it's underscore the name that I was assigned to. So that's going to be underscore, what was it? Self.attername. And that's it. Yes, I'm sweating. Right? Now there's lots of, so let's do the following. Let's do this. I'll comment this out. I know there's a shortcut for it, but I'm too nervous to remember. Please don't judge me. So I'll comment that out, and I will do the following. In setName, I'll print, inside setName, I'll print the CLS and the attername. And if I run the code, I should get 4 prints, because setName will be called twice. Let's actually, yes, I can cut this, so there's less stuff. And I will be called once with the first and once with the last. So if I run this, is it private? Yes, it is. See, inside setName, the first time I got the person class, it's not an instance, it's the class and the first. And the second time I got the person again and the last. And so I'm saving this for each instance of my descriptor, I'm saving the information of the attribute name. Now if I restore the thing that I cut, of course I cut the wrong thing, what am I doing? No. I have to write it again. So what I'll do is, oh, I know, I can just undo. Excellent. I'm so clever. Okay. So now, when I do, no, I need to rerun it because I didn't get it in the first run. Exactly, so I got the prints nonetheless. And now I'll create a John Smith. And now if I do John.first, this looks like an attribute. I'm going to look it up in John. John doesn't have it, but the class does. But wait, first is a thing that has a get method. So I'm going to run the get method, and when I go into the descriptor, self is the descriptor and object is the person. But self knows its own attribute name. So the descriptor knows that it was assigned to first on line 15. And so this should work just fine. And I get the name. And let's just make sure that last also works just fine. And I get the Smith. And if I do assignment, hopefully it doesn't work. Of course it works. Right. So then what's happening? What's happening now is that I just defined a name. Where is it? I defined the first in my object John. So now when I do the lookup, I find the first inside the John, and so I don't get to reach the descriptor. So the way this needs to be fixed is by raising an exception inside set. So I would go object value, and I would just throw an error. So this should be enough. Raise, Rodrigo, please don't do this. Stop. Okay, and now this should work. And if it doesn't, you can boo me off stage. Let's do John is a person. John.first, does it work? Yes, it does. Can I assign to John.first? Hopefully not. And I get a Rodrigo, please don't do this error. I forgot the error at the end of the name of the exception. So this is how you can create a general descriptor for read-only attributes. What's the key point of this? It's that you can use setName to notify a descriptor of the name that the descriptor was given, which I find this just brilliant. I mean, you write an assignment and suddenly you know the name of your own variable, obviously in certain contexts. I find this amusing. I don't know if you do. If you don't, there's something wrong with you. I'm sorry. There's no other way to put it. So This was a short look into the world of descriptors. There's lots of stuff I didn't tell you, and then there's lots of stuff that I don't know yet. So there's lots of stuff twice that you can still look up. Now let's do a quick question. Who's used Python before? Probably this didn't change, right? Now the thing is, I forgot to tell you, and I was about to blow my conclusion. Let me define a quick function. It doesn't do anything. Now let me take a look at the things that f has defined. And if you peel your eyes for it, you can find a get here. Can you see the get? What does this mean? It means that my function is a descriptor. And as it turns out, if you dig deep enough, the reason methods work is because functions are descriptors. Let's say it again. So functions are descriptors, methods use descriptors. Did you get that? Have you ever used a function? Okay, so who's used descriptors before? Can I see all hands up because you've all used methods? Right, so everyone has their hand up, and so that's how I used descriptors to control you today. I hope you didn't feel very controlled. Now, I appreciate your time. I appreciate you paying attention to me. My name is Rodrigo. I've written about descriptors and the things I didn't tell you on this QR, well, the QR code takes you to a book that I've written. It's free, so I'm not trying to sell you stuff. Now I'm going to try to sell you stuff. I also do corporate training and online courses and webinars, so if you want to learn more stuff, feel free to chat with me. I like gelato, but I don't make gelato. That was just to throw you off. And again, I write some books. This is one of them. If you have any questions, come talk to me after. Thank you. Or questions now. I think we still have like 3 minutes. Yeah.
What does the underscore argument, the one you refuse to talk about,
right.
does?
I'm not against it. I just didn't have the time. So, did you all hear the question? So the question was, what does this thingy? What's this, right? And we can actually take a quick look by, let's go to a simpler one. Let's do print CLS, print CLS. So I'm going to exit. I'm going to run, this is the descriptors file. And I'm going to create a quick John. Actually, I don't even need a John Smith. So if I do person.name, I'm trying to look up name in the person. But name is a descriptor. So I'm still going to enter get. Now the question is, if I just have the class here, no instance, just the class, what's the person that I'm getting here? None. I'm getting no person. But Python needs to tell me something about the lookup. I need to know why I was looked up. And so I get the information of the class as the third parameter. So if I do this, what am I doing with my life? Okay, so I got the error after the prints, right. So let's focus on this. Let me scroll here. So I'm inside get from line 3. Then I get the person is none, because there's no person. And then if I scroll one line, I get the class that was looked up. So this argument here is always the type of the class. If I have something here, then the next thing is the type of that. But when I have nothing here, then this gives me the original class. Yeah. Yeah, go ahead. I can repeat.
Super quick.
Oh, okay. Yeah,
In the
sorry.
last example, if I change the underscore last or name attribute, it also change first and last, or no?
That's a good question. And the answer is it will. Why? Because if I change this, when I then access first, notice how first, again, it's a descriptor, so it's going to run the get, and notice how the get accesses the... Sorry? No, but again, Python is a language for consenting adults, so you can always do whatever you want. It's just that at a first look, it looks like read-only, but the only thing we did was mimic property. And by the way, property is a descriptor. So property, static method, and class method, those are all descriptors. And that's why you don't usually use descriptors, because the main use cases, they're already accounted for. right? So this is a very powerful feature that you use all the time with methods, with properties, class methods, and static methods, but you usually don't use it explicitly because all of the good use cases were already implemented. Yeah.
Thank you again, Rodrigo. So, applause for this room as well.